Hello everyone. In this video, we will solve word problems on system of equations using two methods. This is the first part. I will put the link of the second part in the description box below. So the two methods that we're going to be working on today would be the tabular method, or making use of tables, and the equal values method. Let's take this first example right here. Cheryl was given 1.5 feet tall tree that grows 1.4 feet per year, and CJ planted a seed that grows 1.7 feet per year. How many years will it take the two trees to be of the same height? So we're going to take the first method here, which is the tabular method. So I'm just going to label this as method 1. So in here, we're going to create a table. So I'm going to write a table right here. So the dimension of the table, it depends on you. You can create more columns, but for this example that we have, we're gonna have this one here. So I'm gonna have 3 rows for this. So the first row that we're gonna have would be for the years, which will be labeled as X. And then the next row right here would be height, which will be in terms of, it's gonna be in feet, and then this will be our y, and then this one right here is another height, because there are two cases that we have here. Again, this is in feet and this is the y. So the first one that we're gonna have would be for Cheryl's tree. So I'm gonna label this for Cheryl, and then the other one would be for CJ. Now for the x, we're gonna start with 0 year, and then it's gonna be 1, 2, 3, 4, 5, and we can add one more to make it to 6. So again, you can add more. So I'm just gonna stop at 6. So then from here, we're gonna fill this table in. So we start with Cheryl's case here. So Cheryl was given a 1.5 feet tall tree. So initially, that is at 0 year. That is 1.5 feet. So I'm just gonna write 1.5. And then it grows by 1.4. So the growth factor, so after 1.5, by the way, this problem would work only if the growth of this, or the growth factor, is constant for each plant. So provided that the growth factor is constant. So we're going to be adding 1.4 each time. So this would come out 2.9. Again, the number that we're adding is 1.4, so I'm just going to label that up here. So that's plus 1.4. Then we add another 1.4 here. And then plus another 1.4, well, plus 1.4, and then plus 1.4, plus 1.4. So again, because that's the growth factor. So after 2.9, 1.4 would be 4.3. Then it's going to be 5.7, plus 1.4 would be 7.1. Plus 1.4 would be 8.5, plus 1.4 would be 9.9. So for CJ's tree, it says that it started as a seed. So that means it doesn't have any height yet. So our height on 0 year is 0 because it's a seed. And then after that, this is growing by 1.7. So I'm going to write plus 1.7 to each of them. So that's plus 1.7. Plus 1.7, plus 1.7, and plus 1.7. So 0 plus 1.7 would be 1.7. And then after that, plus 1.7 would be 3.4. Plus 1.7 would be 5.1. Plus 1.7 is 6.8. So this is 6.8, and then plus 1.7 would be 8.5. Plus 1.7 would be 10.2. So as we can see here, we can already figure it out that it takes 5 years for the two plants to have the same height. So the answer for this one would be 5 years. It's gonna be 5 years for this two plants to be of the same height. And the height of the plant is, that's gonna be 8.5 feet. So in 5 years, they're going to be of the same height. And then again, the height of the plant is 8.5. Now we're going to show the second method here, which is the equal values method. So we're going to come up with an equation that would work for each of these. So on the first one right here, we're going to determine the m M is the growth factor, and then the B is the starting height. So the growth factor here would be 1.4. And then our B is the growth, is the initial height, which is 1.5. So then our equation for the first, or on Cheryl's tree, would be Y is equal to 1.4x plus 1.5. And then, well, the CJ's tree would be the M, or the growth factor, would be 1.7. And then the starting is 0. So then we can go ahead and write the equation as Y equals 1.7x plus 0, which we don't have to write. Now, to solve for this problem using the equal values method, we can, since we say that Y is equal to Y, so then we can go ahead and say that Y is equal to Y. Since Y is equal to Y, then that means 1.4x plus 1.5 is equal to 1.7x, since both of these would be equal to each other, since both of them are equal to Y. That's why it's called equal values method. So these values are equal. Since we have a decimal here in tens place, we are going to multiply all of these by 10 to make it to whole number, and then we're going to distribute the 10 to each of these. Please remember that it should be each of these, because others miss this part. They only multiply it to the first one. It should be to both of them. So this would come out 14x, and then that's plus 15 is equal to 17x. Since we want x by itself, so we're going to subtract 17x from both sides, minus 17x minus 17x. So then our equation this time would come out to be, so we can cross this out. So I'm just going to show the work on the side over here. So that would come out negative 3x is equal to, plus 15 is equal to 0. So then from here, we can solve for x. I will show the work up here. So then we have negative 3x plus 15 equals 0. So we're going to subtract 15 from both sides, minus 15. So then we have negative 3x equals negative 15. Then we divide both sides by negative 3. Divide this by negative 3. So then we are left with x is equal to positive 5. So this is the year. It takes 5 years for the two plants to be of the same height. Now, to get the 8.5, we can plug the x back into the equation that we have here, so that 1.7 times 5 would be 8.5, which is the height of the plant in the 5th year. In this work that we have here, this table right here is our method 1, or the first method. And the second method that we actually did is this equation right here, or this equal values method right here on the side. So I'm just going to label this as method 2. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, and pause it and check your answer. Okay, so we go over the problem here. So it's pretty much the same thing. So we, again, we have method 1 here. So I'm going to show the first method on this side. So first, we're going to create the table of values. So we're going to start with a table right here. So that's going to be, that's 1, 2, 3. You can create more columns here. That should be fine. And then we're going to have 3 rows. So this is for the month, since it's talking about month here. And so this will be the x, and this is the height of the plant. And this is y, and the height here for the second case, which is y. The first one is for Gwen, and the second one is for Joril. Okay, so in the problem, it says that Gwen bought a 0.8 plant. So by the way, this is 0, 1, 2, 3, 4, and 5. So we're going to start with 0.8 for Gwen, and then it says that it grows 1.5, so we're adding 1.5 each time. So this would be 2.3, this would be 3.8, and then 5.3, and then we have 6.8 and 8.3. Again, we're adding 1.5 each time for Gwen's part. And then for Joril, it says that he bought 1.2 inch plant, so that's the initial 1.2, and then it's growing 1.4 per month, so we're adding 1.4 to each one of these, so then this would come out 2.6, and then this is 4, 5.4, 6.8, and 8.2. So as you can see here, these two plants will be of the same height on the 4th month. So that means on the 4th month, so that's gonna be 4th month, they're gonna have the same height at 6.8 feet. So it's gonna be on the 4th month. So that is the answer to this question right here. So how long will it take for these two plants of the same height? It takes 4 months for them to be of the same height, and the height of the plant is 6.8. Now let's use the equal values method for this, so that we have our M for this problem is the growth factor. That's the one that we're adding each time. How much is it growing every month? So this one's growing 1.5 feet, and then the starting height of the plant is 0.8. So then the equation that we can have here would be y is equal to 1.5x plus 0.8. And then the other problem that we have here, the growth factor or the growth rate would be 1.4, and then the starting is 1.2. So then the equation would come out to be y equals 1.4x plus 1.2. Equal values method, it means that since y is equal to y, that means that these two circled equations would be equal to each other. So that's gonna be 1.5. So I'm just gonna show the work down here. So that's 1.5x plus 0.8 equals 1.4x plus 1.2. Since they are in decimal, we want to get rid of the decimal by multiplying this. Since this is in tenths place, so we're going to multiply this by 10 to each of them. Again, please be careful because others are multiplying 10 only to the first part. That is not the way how we do it. It has to be to both of them. I mean, to all of them inside the parentheses. So this would come out 15x plus 8 equals 14x plus 12. And then from here, we can subtract 14x from both sides. So minus 14x. So then we can cross the 14x out. And then we're left with 1x. So we can just write x plus 8 equals 12. Now we're going to subtract 8 from both sides, minus 8. So then we are left with x is equal to 4. So then we can cross this out. So x is 4. So it means that it takes 4 months for these two plants, the plant that was bought by Gwen and the plant that was bought by Joril, to be of the same height. And if we want to know what is the height of these two plants after 4 months, we can actually plug this value of x up here, so it can work to any of them. So we can go ahead and just use the first equation. So that would be y equals 1.5x plus 0.8. So then from here we can plug the 4 into the x. So 1.5 times 4 plus 0.8. Then we write the 4 here. So 1.5 times 4 would be 6 plus 0.8 is 6.8, which is our y, which was we assigned our y as the height. So this is the height of the plant, that's 6.8 feet after 4 months, and that's actually the same height for both of them. Did you get the same answer as this? Good, perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!